All right, in this unit, we're going to be learning about vectors. This is day 1. Today's objective is to be finding magnitude and direction, find the length of the vector, and the direction. And we're going to be graphing it also. So, a vector, what is it? It's a quantity that has both magnitude and direction. You usually represent a vector by using an arrow. The length of the arrow represents the magnitude. The arrow indicates direction. So, a vector has an initial point and a terminal point when you graph it on a coordinate axis. So, here we have vector PQ. We're going to take the actual points and subtract. So it's kind of like x comma y, but here I'm labeling it as P1, P2. Q1, Q2, we're subtracting Q1 minus P1, and we're subtracting Q2 minus P2 to get both of the components of the vectors. And if you notice, they have the vectors written in these weird looking less than, greater than symbols. The magnitude or length of a vector, this is the symbol that represents magnitude. It looks like an absolute value, but it's 2 bars going up. And it's the square root of taking my subtraction piece and squaring it, plus taking my p's there and q2 minus p2 and squaring it, do the square root of that. So we're going to look at a couple of examples here. So the first one says, find the component form, the magnitude of the vector that has the initial point P and terminal point Q, then graph that vector. We could graph it first if you'd like. So let's see, we have our P. Let's say we have number 1. We're going to be doing our component form for PQ vector, and that formula was taking my Q1 and subtracting it from P1. So I'm doing 5 minus 3. And then the other piece is 6 minus 2. So my vector here is represented as 2. 5 minus 3 is 2. 6 minus 2 is 4. 2, comma 4 is the vector. To get the magnitude of this vector, remember that's that absolute value bars, I'm going to be taking what we just got, the vector, and I'm going to be plugging it in and squaring each component of the vector, the 2 and the 4. And let's work this out. I get it to be the square root of 4 plus 16, which is the square root of 20. So this is my magnitude, my length of this vector. Now, if I am going to graph it, I'm going to be graphing the actual component form of the vector, which is the 2, comma 4. So 2, comma 4 right here. And the arrow is always going from my origin towards the direction of that vector, and there it is. All right, let's try number 2. So number 2 says I'm going to be taking my Q1, subtracting it from P1, and I'm going to be taking my Q2 and subtracting it from P2 there. So we're going to be doing 6 minus negative 2, and then negative 2 minus negative 1. So I get it to be 8, comma, when I add those two together, I get it to be negative 1. So this is my component form for PQ. I'm going to now do the magnitude. So the magnitude again is that formula, square root. What am I going to be plugging in? My 8 squared plus negative 1 squared. And I get that to be the square root of 64 plus 1. So the magnitude, the length of this vector, is square root of 65. And then what do I graph? I graph again this one right here, the 8, comma negative 1. So 8, negative 1 is right here. And then I do the direction from the origin towards that point, right like that. Okay. Now I'm giving you a vector, and I'm asking you to find the component form and the magnitude of the following vector. Well, let's label what these points are. So the point down here is -2, comma, -8. And the point that is going to is 4, comma, -4. So our beginning point, initial, and our terminal point is the Q. So I'm going to be doing the same thing that I did before. We're going to be subtracting my P1 from the Q1 and my Q2 and the P2. So I'm going to do 4 minus -2. And then for this one here, I'm doing -4 minus a -8. So I get it to be 6, comma, this comes out to be 4. So 6, comma, 4 is the the component form, component form, 6, 4. And my magnitude, I go ahead and do my square root, and I'm going to have 6 squared plus 4 squared, which gives me 36 plus 16, and the magnitude here is root 52. All right, now a vector has horizontal and vertical components. I is the horizontal, kind of like the unit circle, 1, 0. J is the vertical, so sometimes when we name vectors, we're going to be using I and J in the equation, or it could be like this, AI, comma, BJ. We have something called a unit vector that has a length of 1 also. So we're going to take these vectors. Here's an example. I'm giving you 2 different vectors. V is this, and W is this. I'm asking you to figure out how to add them together, subtract them, multiply, and do all these things to it. So it's basically just like you do in algebra, you're combining like terms. So here I'm doing 2i plus 3j. I'm going to be adding on to it 3i minus 4j. So when I add these together, I'm combining my like terms, so I get 5i's. And then 3j minus 4j is negative, that's an I, 1j. So there's the answer for the first one. Second one, I'm subtracting. So I'm doing 2i plus 3j, and I'm going to minus 3i minus 4j. So you got to watch your subtraction piece here. 2i minus 3i is negative 1i. 3 minus a negative 4j is positive 7j. Okay, keep going on. Now I'm multiplying this by 3, so I get 6i plus 9j. This one here I'm going to be multiplying and then subtracting. Okay, so when I multiply by 2, multiply by 3, and then I subtract, this is what you should have gotten. Be real careful of distribution and your subtraction. All right, and last one is doing the magnitude for v. So that's the square root thing again. And I'm going to be taking my v, 2 squared plus 3 squared. So I get it to be 4 plus 9, which is magnitude of v is root 13. All right, last thing we're going to be learning for day 1 is what is a unit vector. It's a vector whose magnitude is 1. To figure out a unit vector for a vector is we're going to be taking the vector and dividing it by its magnitude. So that's the formula to find a unit vector. So let's take a look at this example here. To get the unit vector for 4i minus 3j, I got to get the magnitude for this vector first. So let's go ahead and do that. So that's 4 squared plus negative 3 squared. Square root of 25. So my magnitude for this vector is 5. So I'm going to take my vector and I'm going to divide it by each component by the magnitude here, which is 5. So my unit vector for the first example is 4/5 I minus 3/5 j. All right, let's take a look at more 2 examples. Let's get the magnitude first for this one. When I do the magnitude, I get it to be, let's see, 25 plus 36, which is the square root of 61. So I'm going to be taking my vector, negative 5, dividing it by the magnitude. And I'm also going to be taking the 6 divided by the magnitude. You're not allowed to have the radical in the denominator, so I need to rationalize. So that means I'm going to be multiplying the top and the bottom by root 61 for both of these. And when you do that, you get it to be negative 5 root 61 over 61, comma, 6 root 61 over 61. This is my unit vector. Okay, when I get the magnitude for this one here, I get it to be square root of 13. I'm dividing each part of the component of the vector by the magnitude. I need to rationalize, like I showed there, to multiply top and bottom by root 13 over root 13, and this is what I get for my final answer.